Welcome to week 9, and we are going to talk about climate in week 9. And in this first video, we're going to get into the details of exactly what climate is, how it's measured and represented, and then in video 2, we'll talk about the different types of climates that exist on the planet, and we'll talk about some of the controlling forces of these different climates, which should be a little bit of a review from the past several weeks of the course. So what is climate? Climate can be determined and described as the weather over an extended period of time for a single location or a single region. So for instance, looking at the climate or the weather, the temperature for Hood River for the last 100 years or the last 50 years, or the weather temperature highs, temperature lows, max mins for a certain city, maybe for the entire state of Oregon. So that would be looking at these weather elements over a large period of time. That's how climate is different from weather. Weather is what is happening right then and there at one point in time, whereas climate is over a span of time. Climate data usually includes average, for instance, average temperature, or extremes such as extreme highs and extreme lows, along with the frequency of unusual weather events. So it could be average precipitation, extreme high precipitation values, extreme lows, so on and so forth. Basically, any kind of weather data can be put into these climate trends. So how do we measure and represent climate? Well, usually it's one location, so a city, for example, and basically you take data over a specific period of time and do some statistical analyses of that weather data over that extended period of time. And usually it's produced in a graphical or table format. If you're looking at a region, say maybe the Pacific Northwest or a specific state, you can do those same analyses over many sites within one region and compile all that data into one table and graph. So some of the things that we see as a result, this is an example of both past climate data and current climate data for Albany, New York. And what you see is in the top graph up here, we have temperature in Fahrenheit listed. The blue, dark blue line on here that's superimposed on top of these other color stripes is the current or actual recorded temperature for 2013. And you can see this data was taken from the website at the beginning of May. And the data behind that is showing you in the green stripe here in the middle is going to be the average or normal temperature range for this area. Anything above that green stripe in the pink area on top here is going to be what the recorded max would have been for that specific day in that month. And then the purple below here is going to be the recorded minimum for that day in that month. This is also showing the precipitation. So we have a few different things here. We have the green again is the normal, what they expect to see. All on here we see that we have below normal precipitation because we see that kind of green, brownish area on the map or on the graph here. And then below that we have snow in inches. So we see we still have pretty much below normal conditions for snow for that time period. We can also look at climate tables and charts like you see here. This is a statistical summary of weather for a specific area. This is for Baghdad, Iraq. You can see they've taken an average of the monthly high, the monthly low, warmest ever temperature for that month, coldest ever temperature for that month, average dew point for the month, and then precipitation in inches for the month. So you can see in this case here, instead of having daily, like we had here, we have daily points throughout each month on this graph. This one, we have averages for each month on this graph. So you can see this information reported in a variety of different ways. We can also take that data and plot it on a map. This is a great website to visit. I have a link to it on the course page. This basically shows you the globe and what the global June 2010 temperature was compared to the 1971 to 2000 average. So basically the different numbers here is showing you how different the global temperature was in June of 2010 compared to the average from that time frame. So anything that's white on the map is going to be no change, it's going to be the same as that average. Anything in blue is below that average from 1971 to 2000. And anything red is going to be above average temperatures. So this is often how a lot of these this data is represented in a map, is taking an average for a long time span of what the weather data would have been over this huge time frame, and then comparing it, the difference of current conditions to that average, and see how different are we in that time frame. So here you can see all this data. There's the west coast of the US. Looks like it's below average, whereas the northeast, southwest, the middle of the US into Texas, all that would be higher than average. So we see a variety of different things here. All of Europe, Middle East, Africa looks higher than average. So usually we see this represented in maps, such as this one of the US. So this is showing the difference from the average temperature for each state. So this data was taken, the average data that the current 2012 temperatures were compared to is the average from 1981 to 2010. Red indicates areas that are, the darkest red is going to be up to 8 degrees warmer than the average. Anything blue is going to be up to 5 degrees cooler than average. And so we see an interesting trend here. Again, just like that previous global map we saw, the northwest looks cooler than normal, and the middle of the country looks warmer than normal, and then the east, southeast, northeast side is kind of a mixed bag, comparing that data. So this is what you usually see. You usually see maps presented in a way where you see the difference from the average. Oftentimes you can get a map that just shows you what the average temperature was for a specific year, the average for the whole year, or oftentimes they'll pick summer, so June versus December, January type dates. But you can also look at it in the graphical format as well. And we're going to visit this website here, which I can pull up for you now. This data that I gathered came from this Climate at a Glance website that we'll be looking at in lab. Basically, you can pick the US, you can pick the parameter here, precip, cooling degree days, heating degree days. That basically means days, how many days were they're cooler than normal temperatures, and then heating degree days would be warmer than normal, and then various other information there. And then you can click your time scale. So you can say I want just yearly, I want to know what the yearly average was. You could do previous 12 months from today, year to date, so on and so forth, monthly, all sorts of good stuff. And then you can pick what month you want the data for. And then you can choose your start year that you want your graph to begin and when it ends, and you can choose your region. You can do the entire US, and you can do various states, agricultural belts, and then you can click statewide, different divisions of the various states, then you hit plot and you get a graph. And I have taken these graphs for you to look at in the few slides we have. You can also download the data in Excel format, which is probably what we are going to do in lab, so we can graph all this various data. So here we have what one of these plots that the website produced look like, and we can see temperature in Fahrenheit on the left, temperature in Celsius on the right, year across the bottom. And you can see each data point we have here is showing you the average temperature for that specific year in January is what or December is what I chose for, or this one's for April, sorry. And you can see how it kind of bounces back and forth throughout the years. If we were to draw a trend line on this, we might see a slight increase over time since 1900 in our average April temperature. Of course, you might see some various things depending on what month you choose. You could choose yearly to see how that changes as well. And then what you're going to do in lab is something similar to lists. You're going to pick various locations. You can pick various locations around Oregon, around the different states. You can do global and plot the same data. So you're going to pick the same time frame, yearly data for this certain month. So all of your data that you're going to collect is going to be the same, and then plot them in Excel and compare them. So the tricky thing here is if you use the website, we can see that our temperature scale is slightly different depending on the data that's shown. So for this one, for Oregon, our temperature range goes from 46 to, it looks like 51 at the top for December. And then in Texas, it goes from 63 to 67. For Florida, we see it's looks like 68 to 72, and then for Maine, it ranges from 29 to 45. So it's hard to see the different variety in temperature in these different climate areas, because we know Texas is pretty dry and warm. Florida is warm and humid. Maine is cool in the and dry in the winter, warm and wet in the summer. So you don't necessarily see those temperature differences represented from the website. But if you were to take all this data and graph it, put 4 lines on one graph, you would definitely see a set difference in what the temperature range is like in each of these different states. And that, the temperature difference, is one of the factors that goes into determining the climate zone each of these locations is in, which is what we will talk about next.